All right, guys, so today we're talking electron configuration. Okay, if you've already watched the videos on orbital diagrams, this is just one more way of writing out what element we're looking at. Okay, so again, this is called electron configuration. To review a little bit, / let you know that we're still using this rule from orbital diagrams. It's the Aufbau principle, okay, where electrons fill the lower energy levels first. Okay, remember, that means that we start at the top and work our way left to right and top to bottom when it comes to finding the electron and writing out the diagrams. We'll go over that more in just a second. Okay, another thing that I want you to remember is when we're looking at the sublevels, if it's in the S block, that means it can hold a total of 2 electrons. If it's in the P block or P sublevel, it holds 6 electrons. D sublevel holds 10. F sublevel holds 14. Okay, so with electron configuration, this is important. All right, as I said, we'll come back to this in the Aufbau diagram. All right, so if we were to do the whole configuration, all right, we would first pass through the 1s's. Okay, so 1s. Then we pass through 2s. If you're not writing this down with me, you should. Okay, then 2p, 3s, then 3p. Now to the fourth period, we have 4s. When we get to the D block, remember it's 1 minus because it has a little bit more energy than the 4s. Okay, so 3d. And then back to 4p, then 5s, 4d, 5p, 6s, and now here's where it gets really funky. Okay, the F is 2 behind. Okay, so instead of saying 6f, we're actually going to say 4f, and then back to 5d, now to the normal period that we're in. 6p, okay, then 7s, 5f, 6d, and that's actually where it stops. Okay, so we're not going to go any further than 6d. But if you want to have this written down, you can use this as a shortcut for later. All right, so again, this is the full order of the electron configuration from lowest energy level to the highest energy level. All right, let's go ahead and start working on some examples, okay? So if we have hydrogen, okay, hydrogen is in the first period, S block, and it's the very first element. So if I were to write my answer for this, I would say 1s1. For hydrogen, that just happens to be it because that's all there is, starting at the lowest energy level, and it's the very first thing listed. So this is the lowest energy when it comes to an element. All right, so we're just going to leave hydrogen as 1s. All right, using the same examples that we did with orbital diagrams, the next we're going to go to is helium. Okay, helium is still in the 1s block, but now there are 2 elements. Okay, so we're going to say 1s2. And again, for helium, that just happens to be it because 1s is the very first thing on our list. All right. So the next example that we're going to jump to is oxygen. And anytime I'm going too fast, pause the video, write down what you need to, and then press play. Okay. Oxygen is right here. Okay. It's in the second row in the P block or P sublevel. Okay. So we're going to go to 2p. So I'm going to say 1s, 2s, because we go through 1s, 2s to the 2p's. But now instead of doing boxes and arrows, I'm just going to be saying the numbers. Okay, so this is where it was important to remember how many electrons that this sublevels can hold. This S sublevels can hold 2 electrons, so I want to put 2 up here. Okay, these superscripts tell me how many electrons there are in that sublevel. Okay, so the 1s holds 2 electrons, 2s holds 2 electrons. And when we get to the 2p, we're not doing all 6 of them, because remember that that p's can hold up to 6 electrons. Nope, we just need 4 to get to oxygen. 1, 2, 3, 4. So I'm going to say 2p4 to make it match where oxygen is. Okay, now if we're wanting to double check ourselves, and I realize that I wrote that it has 2 electrons, but actually it holds 8 electrons. Okay, now if I want to double check that I did it right, what I'm going to do is, remember with the orbital diagrams that we counted all of the arrows, and as long as the arrows match the number here, then we did it right. Well, now we're not using arrows, we're using superscripts. So if I add my superscripts together, 2 plus 2 plus 4 is equal to 8, then I know that I have done it right. So this is your answer for electron configuration for oxygen. All right, so our next example is going to be magnesium. If I can get the paper, here we go. All right, so when we find magnesium on the periodic table, it is right here. It's in the 3rd period, S block, 2nd one over, 3s2, and its atomic number is 12, so that's where I get the 12 electrons from. So now I'm going to look up here, and I'm going to write all the way to 3s. Okay, so we have 1s, 2s, 2p, 3s. Okay, so this is our stopping location, so we know that the final thing is going to match, so 3s2, 3s2. And remember, now we go back and write how many elements that these can hold when full. So s's can hold 2 when full. And do you remember how many p's hold when full? Okay, p's can hold 6 when full, so this is going to be 2p6. All right, and again, we double check by adding the superscripts together. 2 plus 2 plus 6 is 10, plus 2 is 12. So that equals 12, which is what we need. So this is my answer for the electron configuration for magnesium. All right, and my last example to do with you before you try some on your own is going to be cobalt. All right, so cobalt, we know the final is 3d7. Again, we did these with the orbital diagram. It's in the 4th period, but in the D block, so that's why we said 3, and it's the 7th one over, okay? And its atomic number is 27. Okay, so I'm going to start with 1 and write all the way to 3D. So 1s, 2s, 2p, 3s, 3p, 4s, and 3d. We do these long enough, you're going to have this memorized, okay? But again, if you write it on your periodic table, you always have it to reference too, so you don't necessarily have to have it memorized, but it is good to know. All right, so we know we're finishing at 3d7, so I'm going to put a 7 right here, okay? And then my s's have how many? 2. Sorry, I have a 2-year-old, and that's how she says 2. All right, so I'm putting a 2 next to all the s's, and p's have how many when they're full? 6. She doesn't say 6 yet, so that's, I can say that normal. All right, now everybody has a subscript next to it. So to double check that I have the right subscripts in the right places, I'm going to add them all together to see if I get 27. 2 plus 2 is 4, plus 6 is 10, 2 is 12, 6 is 18, plus 2 is 20, plus 7 is 27. And that is what I need. So this is the electron configuration that we need for cobalt. All right, again, we're doing the same problems that we did for orbital diagrams, but now we're writing out the electron configuration. So on your own, go ahead and try lithium, silicon, and vanadium. Hopefully you've paused the video, and now I am just filling in the answers. All right, so here's what I have, and then I'm going to go back and double check that all of these are correct. This one has 3 electrons because 2 plus 1 is 3, so I know that's good. This one has 2, 2, 10, 12, 14, so we know that this one is good too. 2, 2, 4, 10, 12, 18, 20, 23. So we also know that this one is good. All right. If you have any questions, ask your teacher. But again, we're just going to be doing a little bit more practice on this to make sure we understand. Have a good day, y'all.